Hi guys, here is MIH. This is going to be a rather short and boring video about something that many people have done before, but it sort of foreshadows some big projects that I'm going to do soon, the EE and IA. As I study the IB curriculum, we have to do an internal assessment, or IA, for each of 6 subjects we choose, and for the science subjects, an IA is basically a lab investigation. We also need to write an extended essay, or EE, on a subject of our choice. And of course I chose chemistry, despite that many people said science EEs are hard to gain high points. Today's synthesis of hydrobromic acid is the first step of the preparation of many reagents I need in my IA and EE experiments, and I'll cover my entire progress of IA and EE labs in the upcoming months, so stay tuned for that. Anyways, back to the actual chemistry, which was rather simple. Mix sulfuric acid and potassium bromide and distill over the hydrobromic acid. That's it. I first dilute around 140 grams of 85% sulfuric acid in 200 ml of water. The amount of sulfuric acid I use here is 1.21 moles, and since I plan to make 2 moles of hydrobromic acid, this is not yet a stoichiometric equivalent. I was testing this deficient amounts because 1 mole of sulfuric acid can in theory release both of its protons and react to make 2 moles of hydrobromic acid. I thought I can get away with this, but in the end the yield is poor, so still try to use the more reasonable stoichiometry of 1:1 molar ratio. I then weigh out 239 grams, or 2 moles, of potassium bromide, and directly dissolve it in the warm sulfuric acid solution. The mixture immediately turns yellow, which was due to the presence of bromine as an oxidation product of bromide by sulfuric acid, but that cannot be avoided in this process, and cooling the mixture down only minimizes the formation of bromine. Since I prefer speed over yield, I opted to simply dissolve everything as fast as possible. The mixture soon boils and the yellow bromine vapors are pushed forward by the colorless hydrogen bromide vapors. The initial drops of acid are yellow, and their density is only 1.226 grams per mil, which was far from the 1.5 gram per mil of azeotropic hydrobromic acid. After I collected around 20 ml of this rather dilute acid, the bromine color nearly disappears, and I changed the receiving flask to collect nearly colorless hydrobromic acid. However, since I didn't use a thermometer, I had no idea if this acid was azeotropic or not, and from the density diffraction lines you can see here, the acid in the flask was certainly not yet azeotropic, and the acid dripping in it probably is. So I switched the receiving flask again to collect this azeotropic acid. Soon, nearly everything distills over, and a large cake of salt is left in the flask, which was surprisingly easy to dissolve out, unlike the hydrochloric acid and nitric acid runs, probably because that the cake is more porous. For storing hydrobromic acid, I wrapped some Teflon tape around the caps of my storage bottles to create a very airtight seal. I first pour the azeotropic fraction, which weighs 111 grams, to a storage bottle. Its density was determined to be 1.459 grams per mil, which corresponds to a concentration of 46%, so this stuff is quite good. The fraction of rather dilute acid weighs 91 grams, and it only has a density of 1.331 grams per mil, or about 37%. The first bit of acid with a lot of bromine contamination weighs 27 grams and only has a density of 1.1 grams per mil, or 14%. Combining all three, the yield of hydrogen bromide was 88.5 grams, or 54%, which was quite bad actually. I should have used a much larger excess of sulfuric acid to force all of the hydrogen bromide out. But this is more than enough for my IA. See you soon!